Hello and welcome to this tutorial on how to use Excel to create a graph. I know in your lab document it mentions that there would be something available on Canvas. Here is going to be your tutorial. So first off, you'll see how Excel is organized. It's got rows and columns. Now I'm going to take the first row of a couple of columns and I'm going to create some labels for the data that will then follow and be in that column. For example, I'm going to, in the book, or sorry, in the lab manual, it talks about having a snail moving, and it talks about its position during its motion, so its movement over time. I'm going to do the same thing, but we'll use something a little more exciting, like perhaps a skateboarder, something like that. So, position versus time. So I'll start off with time. This is the variable that is going to be on our x-axis. We're going to put the x-axis in the first column. So time, I'm going to put the unit of measure as seconds. I always put the unit of measure in the top of the column. I always want a unit recorded when we create a graph, and I'm going to put it in the column header so that I know what it is. And then I'm going to put position, and I'm going to specify meters. Now, notice this doesn't exactly fit in that column. If I click out of there, it might not always show that. But if I make that wider, it'll fit. If you don't see what I'm doing there, I'm double clicking. I put my cursor right at the border between A and B. And if I double click right there, it will automatically resize it to the widest cell in that column. So, time is my label. And see, I can manually click and drag to make the cell wider or narrower, or I can just double click on it and it will automatically snap to the widest cell. Okay, so over time, let's say that we're doing it in 5-second intervals. Our first will be at time 0, then at time 5 seconds, and then we'll do 10 seconds. Now, obviously, our motion is going to be, if we're doing it at 5-second intervals, we could sit here and go down as far as we wanted to on time, or we have enough cells here that Excel, which is the program we're using, Excel will see this pattern, 0, 5, 10. If I highlight these by clicking in the top cell and then dragging down and highlighting them, notice that it puts a box around it and it gives me a little square at the bottom right corner of that. And if I put my cursor over that, it has a plus sign. That means that Excel sees a pattern and it's ready to copy it down. So if I click there where that plus sign is and then just drag, it will automatically fill in the rest of the cells in that pattern for me. I don't need to continually go down and put 5, 10, 15, 20 and so on. It'll take care of that for me. We'll go down to 50 seconds. That should be enough for a simple graph. Position, well, I didn't actually record this data. We're making it up. So let's say at time 0, he was at 0 meters. At 5 seconds, he was at 10 meters. At 10 seconds, he was at 30 meters. And at 15, he was at 45. We'll just keep making it up as we go here. 60, 80. He's booking it here, by the way. I will say he's a fast skateboarder, and that's okay. 120. Let's see, 160. 200. I'm just making this up as I go. It could be an interesting graph. That's okay. We like interesting graphs. 250. Whoa, 259, whatever. Maybe that's just as good. And then at 50 seconds, he is at, let's say 340. Okay. I just kind of guessed at that. Now, we have our data. To create a graph of that data, let's go ahead and highlight the data set. We do it the same way by clicking in the top cell and then dragging to the bottom right until we highlight all of them. So I just click in the middle of the cell and drag. And very simple stuff. Click with the mouse and drag. Now I go up here to the ribbons at the top. I'm going to go to Insert. It'll automatically change if I'm in Office 365 or Office 2019. And it will change to give me some options of things that I can insert. And then it has this Charts section over here. Now, almost always, if you're plotting two things against each other, like time and position, you're going to use what we call a scatter plot. And in this class, I will want you to use a scatter plot with just the dots. So you go here and click on the little down arrow by charts, choose the scatter plot, and here we go. We have a graph of his motion over time already laid out. You can see here 0, 10, 20, 30, 40, 50, 60. This must represent our time because it coincides with that axis. And then on our y-axis, which is where we want our position, you'll see it coincides with these numbers. So it's already set and ready to go. Now I'm going to add a few details here. I want some axis titles because I want to be able to label the axes. You always want to do this when you graph. If you don't label an axis, we don't know what it is. And that's the only way we're going to be able to specify what unit of measure we used, which is important. It could have been feet, could have been miles, could have been, light years. We have no clue unless we say so. So we're going to say position, and I'm going to say meters. And then this axis should coincide with the title. Whoops, getting a little click happy here. You replace axis title with time in seconds. Okay, we have now labeled our axes. This title up here, I'm not sure that actually makes sense. We could call it position versus time. Skateboard position versus time makes sense. You want the title to actually describe the data that's in it. So this does describe the data, and that's an appropriate title. Okay, we now have completed a graph for our data set. And we're almost complete. The only thing that we'll also include, because we are in a science class, we want to be able to model this data. In other words, we want a formula basically that fits this. The way we do that in Excel is by generating a trend line. The trend line will then approximate a mathematical equation that tries to fit these data points. So if you go up here, you click on the, let me back out. You click on the white area behind the chart itself. Then this little plus icon will appear again. And it'll also have trend line in here. Now, trend line, and I move over here. A linear trend line looks like it doesn't quite fit the lines, or the dots. The line's trying, but it's not quite making it. So let's go try some others. How about logarithmic? Oops. Hang on here. I'm going to want to delete this trend line anyway. So I'll click on it and hit the delete key. Trend line, now 2-period moving average. Does a pretty good job. We might want polynomial moving average. 2-period moving average looks like the best one for us. That's pretty close. Oh, maybe polynomial. Look at that. Second order polynomial. Okay. The one that fits the best is the one that we want. We'll click that. We could have it show the R value, and it could actually show the equation that it came up with. We don't need that. We just really want the dots right now that connect it. This will allow us to interpolate the data, which is to, of course, pick data points where inside the data set, like say for example we have 30, 35, 40, where we had measurements, right? 30, 35, 40, we had measurements. But let's say at 33, we wanted to know about what it was. We could look at the graph and follow it over and figure out about what that number would have been. That's interpolation. Extrapolation is finding the data outside of the data set, so further out. So we can use this line to interpolate our data. Okay, that's how you make a graph in Excel. You can make other types as well. If you had a different type of data set, you could also use a bar chart, and we'll talk about that in class, but this should get you started at least making a graph like the one that you'll need in lab for your pre-lab. So you should be able to graph your snail data using the method that I just showed you here. Good luck.